In Part C of this exam review, we're going to start with some work where you have to show your answers, show your steps. And in the first one, you're just asked to create a ranking question for a survey, in which a person must choose from a list of 5 different sports as most to least favorite. So, and the answers will vary here, but here's an example. The question could be rank each of the following, where 1 is your most favorite and 5 is your least favorite. So you have to have something like this to tell when they assign a number, what's most important, what's least. And so I chose hockey, football, baseball, tennis, soccer. So there's my 5 choices here, and there's a place to write the 1, 2, 3, 4, 5 in whatever order the person chooses. Question number 2, you're given the following data and you're asked to determine the median, the mode, the mean, the range. And so for the first one here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers, so that means in this formula n is 12. For the median, x would be 50, because the median is the same as the 50th percentile. So putting 12 in place of n and 50 in place of x, 12 plus 1 is 13, and 13 times 50 divided by 100 is 6.5. And so that 6.5 means the median is the 6th number plus 0.5, or half the way from 6 to the 7th number. So we use this formula. It's the 6th number plus that 0.5 times the distance between the 6th and 7th number. So 1, 2, 3, 4, 5, 6. The 6th number is 26. The 7th number is 29. So we would do 29 minus 26 here, which is 3. 3 times 0.5 is 1.5. Added to the 26 gives us 27.5. So 27.5 would be the median. Next, in B, we're asked to find the mode, and the mode is the most frequently occurring number. So the mode is 20 because there's 3 20s here. There are 2 25s and 2 31s, but there are more 20s than any other number, so the mode's 20. For the mean, we basically add all the numbers up and divide by how many there are. Now, instead of going 20 plus 20 plus 20, I'll do 20 times 3, plus there are 2 25s, so 25 times 2, plus 26 and 29, and there's 2 31s. And a 36, a 38, and a 40, and we would divide that by 12. That whole numerator should add up to 341. 341 divided by 12 is 28.4, so that is the mean. The range is the difference between the largest and smallest number. So 40 minus 20 would be 20, so the range would be 20. Flipping over to the next page, some more questions about the same data. We're asked to find in E the standard deviation, and this is the formula for the standard deviation. So it's 3 times the number minus the mean squared. 3 because there's 3 20s, plus, and there's 2 25s, so plus 2 times 25 minus the mean 28.4 squared, etc. And all the way through over n minus 1, so we're actually dividing by 11 here. This whole calculation in the numerator should give you 538.92, so we divide that by 11 and you get 48.927 repeating. And then in order to find the standard deviation, we would take the square root of that, because this is s squared, and we get almost exactly 7. It's like 6.99, etc. So the standard deviation is 7 to 2 decimal places. To find the lower quartile, upper quartile, and then we're going to draw a box and whiskers plot down here. The lower quartile, similar calculation to the median, except it's the 25th percentile. So x is 25, so we'd have 13 over 100 times 25, which is 3.25. The third number, and remember the first 3 were all 20. So the third number is 20, and the fourth is 25. So the third number, which is 20, plus the 0.25 times the fourth minus the third, 25 minus 20 is 5. 5 times 0.25 is 1.25. Added to 20 would be 21.25. So that's the lower quartile. To find the upper quartile, that's the 75th percentile, so we put 75 in place of x, and we get 9.75. So it would be the 9th number plus the 0.75 part times the 10th minus the 9th. Well, if we go back up and take a look at our numbers, which one are the 9th and 10th? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the 9th, 36 is the 10th. So 0.75 times 36 minus 31, which is 5, 5 times that added to 31 gives us 34.75. So the upper quartile is 34.75. So the box and whisker plot looks like this. Lower quartile is the 21.25. The median was 27.5. Upper quartile is 34.75, so that's the box part. This whisker goes down to 20 because 20 is the lowest number. This whisker extends up to 40 because 40 is the highest number. So there's the graph. Going over to the next page, so now we have interval data, and we're asked to calculate P20, find the 20th percentile, and the median as well. So in the, I believe in the student paper, this part wasn't completed. You just had the classes and the frequencies. So this frequency would be 4. If you add 4 to 7, then the cumulative frequency for the second category is 11. Plus 12 gives you 23 here, 23 and 9 it's a 32, 32 and 6 add to 38, and 2 more for this frequency makes the cumulative frequency there 40. So there's 40 data, 40 numbers in this set of data. To get each of the cumulative percentages, divide each of these by 40. So 4 divided by 40 is 10, or 0.10, which is 10%. 11 divided by 40 gives us 0.275, so 27.5%, etc. So right up to the top here. Now, this is the percentile formula for interval data. And in this example, we're asked to find P20, so it's the 20th percentile. So X is 20 here, and we put 20 here. N is 40, because the cumulative frequency would be 40. The lower LX stands for the lower end of the interval. 20 is between 10 and 27.5, so the bottom of this interval would be 5. LX is 5. And the width is 5. It's 5 from 5 to 10, or 5 from 10 to 15, so that's why I is 5. So 40 times 20 over 100. The sum of F sub C is the cumulative frequency total before this interval. So we're talking about the second interval, so we would use 4 for that one. And F of X is the frequency for this particular interval, which would be the 7 here. That's why 7's here. So this is what the calculation would look like for, we'd start in here, 40 times 20 divided by 100, which is 8. And so this is 8 here, minus the 4 would be a 4, and then divided by 7. So we would go 5 times that 4 divided by 7. So that rounds to 2.9, so that's why this is going to be 2.9. So 5 plus 2.9 would be 7.9. So the 20th percentile would be 7.9. To find the median, not too much difference in the calculation, except, of course, X is 50 for the median, so 50 here. The median, see, here's 57.5, so the median is in the third interval because it's above 27.5 but below 57.5. So the cumulative sum before that interval is 11, so that's why 11 goes here. And the frequency for this particular interval that 50 is in would be 12, so that's why we have a 12 in place of the F of X. So, bringing our calculator back, 40 times 50 divided by 100. So that works out to 20. 20 minus 11 would, of course, be 9. So we have 9 over 12. And actually, 9 divided by 12 is 0.75. So we're multiplying this 5 by 0.75. So this is 3.75 added to the 10 would be 13.75. I'm not sure if I talked about the 10 here. 10, of course, is the bottom of this interval, so we're talking about the third interval, so that's why 10 would be the L of X. So the median is 13.75. In question number 4, we're asked to find the regression equation, and we're given that there are 12 data points, n is 12. And this is what you're given. The formula to find A, which is the slope of your regression equation, is the n value times the sum of xy, the product xy, minus the product of the sum of x and the sum of y, divided by n times the sum of x squared minus the sum of x all squared. And so we're just filling in all these values. So n's 12, so 12 goes here, and 12 goes here. The xy sum, 81,899, goes here. Sum of x, sum of y, so 450 times 613 here. again 12 there. The sum of x squared, the 39,956 right here, and the sum of x all squared, so we're squaring the 450 here. And so this is what I would do. I would probably go put a bracket. So 12 times that 41,899 minus 450 times the 613, close the bracket, and then divided by, and I'll put in brackets as well, on the bottom, in the denominator we got 12 times the 39,956 minus 450 squared. And I'll close that bracket. And I see what I did wrong. There's supposed to be a subtraction sign here. So one of the nice features of the TI-83 Plus is you can just go second enter and bring what you did up. There we go. Now I have the right answer, 0.819. So that's the slope. For the y-intercept, the b value, it's the sum of y divided by n, the 12, minus the slope value, rate, times the sum of x over n. So let's see if we can get this one right the first time. So the sum of y is the 613, so 613 divided by 12 minus the 0.819 times the sum of x is the 450 divided by 12 again. There we go, 20.37. So that's the b value. So the equation, an regression equation would be y equals 0.819x plus the 20.37. For the next question, number 5, we're told that this farmer has recorded the heights of a sunflower over several days and used her graphing calculator to determine a linear regression equation relating the height to the number of days it's been growing. And her graphing calculator image looks like this. So this is telling us that the a value is 1.18 it would round to, and the b value is about 0.75. So a regression equation would be y equals 1.18x, so we're putting the a value in place of the a here, plus the 0.75, where x is the number of days and y is the sunflower height. In B, we're asked to use the equation to predict how tall the sunflower will be after 30 days of growth. So x is the number of days, so we put 30 in place of x here. So this is what the calculation would look like. So we would go 1.18 times the 30, and then add the 0.75. So 36.15, so you expect it to be a little over 36 centimeters, or around 36 centimeters. And you're asked, is this a positive or negative correlation? Now, this would be a positive correlation because the slope, the 1.18, this value right here, is positive. If it's positive, it's a positive correlation. And you're asked now in D whether it's weak, strong, or neither. Now, if you look at the R value, 0.99, it's pretty close to 1. It's very close to 1. The closer it is to 1, the stronger the correlation. So we would say it's quite strong. Flipping up to question number 6 on page 11, you're asked in number 6, how many arrangements of the words in the letters in the word environmental begin with an L, T, M, or V? Now, L, T, M, or V, there are 4 letters there. Now, once we say that there's one of these 4 choices to be at the beginning, there's and you should count, there's 13 letters there altogether. So there's 1 letter here, and there's 12 other letters. Now, of those, all the letters here, notice that there are 1, 2, 3 identical N's and 2 identical E's. So if there weren't letters the same, it would just be, if they were all different, it would just be 4 times 12 factorial. But the fact that some of those letters are the same, it's like, if I were to take this and have all these letters, if I were to take that N and switch them, you wouldn't know the difference. It would look exactly the same. So when you have repetitions of letters, it decreases the number of permutations you have. So we divide the 12 factorial by 3 factorial for the 3 identical n's and 2 factorial for the 2 identical e's. And so this is what the calculation should look like. 4 times 12, and that's not what I want to go in here, factorial, divided by, and on the bottom we would have 2 factorial times 3 factorial. I don't need to type in the multiplication. And so that, let's see now, 159,667,200 is the number of possible ways those could be arranged. Number 7. How many ways can 15 people be arranged in a line with no restrictions? So if there's no restrictions, we're not saying somebody has to be first or last or beside one another, then it's just 15 factorial, which would be about 1.3 times 10 to the power 12, so a pretty big number. Now, for B here, it says that Evander and Melody are not in speaking terms, so they don't want to stand next to each other. So in order to do this B here, there's a long way and a short way. I'm going to show you the quicker way to do it. So let's say we wanted to have Evander and Melody together. So I put the E and the M beside one another. So what you do is you think of that as that pair of people as one thing, and then there's 15 people altogether, so I have 13 other spots here. So it's like you're arranging 14 things. So the number of ways that they could be together would be 14 factorial. Now we have to multiply that by 2 because you can have Evander first and Melody second, or the other way around. So we'll multiply that by 2. So 2 times 14 factorial is the number of ways they could be together. So they're either together or they aren't. If you take those two possibilities and add them up, you get the total. So one way to calculate the number of ways that they are not together is to take the total and subtract from it the number of ways they could be together. And that would give you the number of ways they're apart. So that's one way to do B. Otherwise, you'd have to say, well, let's say Evander's in the first spot and Melody's 2 after him, or 3 after him, or 4 after him, 5 after him. Okay, it's a very, very long calculation. So this is by far the simpler way to do it. Number 8, the athletic director surveyed his male and female athletes and collected the following data. We have 24 people that play basketball, 27 played volleyball, and 29 played badminton. 18 played both basketball and volleyball, 16 both badminton and volleyball, 14 basketball and badminton, and 10 played all 3 sports. You're supposed to arrange this in a Venn diagram. So this circle or oval will represent basketball, this one volleyball, this one badminton. Now, you start in the middle when you figure these out. So we put 10 people playing all 3 sports right in the middle, so because that's an area in which all 3 of these basketball, volleyball, and badminton overlap. So 10 people go here. Now it says 14 people play both basketball and badminton. Okay. Now basketball and badminton would be this part right here. 14 people in there altogether. Now if we already have 10 here, then we would only put 4 here to make a total of 14 here altogether. 16 participate in badminton and volleyball. Well, where's badminton and volleyball? Badminton and volleyball is this part right here. We've already got 10 there, so if there's going to be 16 there altogether, we need just a 6 here. And next we have 18 that played both basketball and volleyball. So 18 in this oval here, already got 10 here, so I only need to put 8 there to make the 18 altogether. Now it says 24 played basketball. So 24 in this oval altogether. We've already got 10, 4, and 8 in these 3, so that's 22. We want 24 in this altogether, so I put a 2 right there to make 24. For the volleyball, there's 27, so we already got 8, 10, and 6, that's 24. So we need just 3 people out here that only played volleyball. And then 29 played badminton, so 4, 10, and 6 is 20. So we put a 9 here because there's 29 here altogether. So that's the Venn diagram. Now we're asked some questions about this. How many people played at least one sport? Well, we just add up all the numbers. So 2, 8, 10, 4, 6, 3, and 9. And those add to 42. So 42 people played at least one of the sports. How many people played only badminton? Now, only badminton is this 9 here. because, for example, that 4 here played badminton, but they also played basketball. So we just want that 9 for question C. How many played basketball and volleyball, so basketball and volleyball, but were not interested in playing badminton? So basketball and volleyball, but we don't want to see them in here at all. Okay. Now, there were 8 people that played basketball and volleyball. Okay, so we wouldn't want to include this 2 or this 3 because that's just basketball, that's just volleyball. But we don't want people that play badminton. Okay, so that 8 is what we're looking at here. They play basketball and volleyball, but they're not in the badminton set at all. So that's D. How many played only one of the sports? Now, only one of the sports would be the 2, the 3, and the 9. So 2, 3, and 9 should add to 14. And lastly, how many played exactly 2 of the sports? Well, 2 of the sports are where 2 of the circles or ovals overlap. So we want this 8, this 4, and this 6. The 10 is people that played all 3 sports. You don't include that. So 4 and 6 is 10 plus 8 should be 18. So 18 for F. In question number 9, it says, in how many ways, and I guess I should have had the word can, 20 people be arranged into 4 equal size groups. Now, equal size means they all have to be 5. 20 divided by 4 is 5. And if it's just a group, it's a combination. We're not saying that order has to be important here, so it's just a group of people. So the first group could be chosen in 20 choose 5 ways, times, then the next one there's only 15 people left to choose from because 5 are already in the first group. So times 15 choose 5 for the second, times, now there's only 10 people left for the third group, so 10 choose 5 times, and then 5 choose 5 for the last one. So if we evaluate those combinations, and you may have a calculator that will allow you to do the combinations directly rather than using the factorial. So that's the 15504 is that one. This one, all I have to do is change this first number to 15 now, so that's the 3003, and then I could do 10, it's 252, and 5 choose 5 is 1. So we multiply those out, so it's a pretty big number, lots of ways that you could select those groups. In groups of 10, 5, 3, and then 2. So the first group of size 10 could be selected in 20 choose 10 ways. Then there's 10 people left for the next group of 5, so 10 choose 5. And then there's 5 people left for the next group, so 5 choose 3, and then 2 choose 2 in the end. So that would be the number of ways we could select groups of those sizes. Now it would have to say in that specific order. You change that order around. And actually, I was just starting to say that if you change the order, you're going to change the number, but that actually isn't true. I paused for a second here, and so in the example I did 10 first, 5 second, 3 next, and 2 last. So if instead I did the 5 first, we could choose those in 20 choose 5 ways. And then let's say we did the 10 next. So we'd have 15, because we already used 5. 15 choose 10 for the second, sorry. And then there's 5 left now, because we've taken 5 and 10 out. So let's say we did the group of 2 and then the group of 3 in the end. So 5 choose 2 and 3 choose 3. It actually works out to exactly the same. So it really doesn't matter what order you do that, the 10 first, the 5 next, etc. So it really wouldn't matter. For question number 10, Fabiola places 7 blue, 4 red, and 10 brown marbles in a container. And she selects 6 marbles at random without replacement. Now, if it's without replacement, then this is the hypergeometric probability distribution, because the probability of getting any color would change from trial to trial if you're not replacing them. If you were replacing them, and the probability of a red or blue or brown would then stay the same, so that would be binomial. So we're using hypergeometric. Now, we're asked what's the probability of exactly 4 blue marbles. So we're identifying the blue as the special kind of thing. So that's why the A would be 7. Now we're selecting 6 altogether, so that's why R is 6. And 7 and 4 is 11, plus 10 makes 21, so N is 21. So in the formula, we'll replace, so A is 7, so this will be 7 choose X here. N minus A, 21 minus 7 here, would be 14. And then R is 6, so 6 minus X, and then N choose R would be 21 choose 6 in the denominator. Now we're trying to find the probability there's exactly 4 blue, so the little x would be 4. So we would go 7, choose 4, 4 here, 4 from 6 is 2, and 21, choose 6 in the bottom. And so if we evaluate this, 7, choose 4 is 35, 14, choose 2 is 91, 21, choose 6 is 54,264. Multiply that, you get this. It actually reduces a bit, but if you divide it, you get 0.059, so it's about a 5.9% chance. In B, it says, what is the probability she will have at least 4 blue marbles? Well, at least 4. At least 4 means 4 or more. Now, remember, she's choosing, how many we do in here? 6, right, 6. So at least 4 would be, the probability would be, at x is greater than or equal to 4, would be the probability of 4, 5, or all 6. And so we're doing the same calculation as before. Now, this one here, this 4 here, is that exact same calculation. So to change it to 5, we would go 7, choose 5, and notice that instead of 14, choose 2, it's 14, choose 1 now. Notice that that number and that number have to add up to the 6. 21, choose 6 in the denominator. And of course, if x is 6, we would do 7, choose 6, and then 14, choose 0, because if x is 0, it would be just a 6 in that. Sorry, if x is 6, we would have a 0 in the end here, over 21, choose 6. So this is the calculation from the last question. 7, choose 5 times 14, choose 1 works out to, actually, let me just show that calculation. So we have, let's see now, 7, choose 5 times 14, choose 1 divided by 21, choose 6. Now that's it as a decimal. I don't have that written here. If you want to know what it is as a fraction, that's where the 7 over 1292, that's actually reduced. So this would reduce a little bit. It was a little bit larger than 7 over 1292. The calculation on the end, see the only difference is 7 choose 6 instead of 7 choose 5. So all I'd have to do is go up here and edit that to be a 6. And it becomes 14, choose 0, so I need that to be a 0. And of course, if you want to see what is a fraction, oh, it's too small. Okay, I could actually show the combinations, I suppose. But this would all add up to 0.064, so it's about 6.4% chance that that would happen. In C, you're asked, what's the expected number of blue marbles? And the expected value formula for the hypergeometric is RA over N. So R was 6, A was 7, N is 21. 6 times 7 is 42, divided by 21 is 2. So the expected number, the most likely one, would be 2 marbles. 2 blue marbles. So for question number 11, we're told that David believes he has about a 10% chance of winning on any particular play of the game, something on a certain lottery, instant lottery he plays, and he's gotten in the habit of playing once per day. So you're asked, what's the probability that David wins 5 times during the month of January? Well, this 10% chance of winning, we would define that as the probability of success. So P would be 0.10 or 0.1. Then Q would be 0.9. And this would be binomial because he thinks his probability chance of winning is the same every single day. So, okay, so the probability is not changing, so that's why we use binomial. Now, N would be 31 because there's 31 days in January. And we're trying to find the probability he wins 5 times. That's why the little x is 5. So 0.1 to the 5th, and then the 0.9 is that's probably losing, to the power of 31 minus 5 would be 26. So that's the calculation. So we would go 31, choose 5. So that's where the 169911 comes from. And then times 0.1 to the 5th is this number, 0.9 to the 26th is that number. Multiply them, you get 0.109, etc. So he has about an 11% chance of winning 5 times during the month of January. What's the chance of David winning at least once? Well, now at least once would be 1 time, 2, 3, 4, 5, all the way up to 31. So you could do all those probabilities and add them up. Okay, that would work, but it's pretty long. So an easier way to do that would be to find the probability he doesn't win at all and subtract that from 1. Okay, because he either wins once or more, or he doesn't win at all. That would be the probability that x would be 0. So same probability formula from A here, but we're going to find the probability he doesn't win at all and subtract that from 1. So if we would do no winnings would mean x is 0. So 31 choose 0, 0.1 to the 0, 0.9 to the, see if x is 0, this would be 31 here. So this, now actually that's 1, and this is 1. So we actually have just 0.9 to the 31. If we do that calculation, 0.9 to the power of 31, 0.038. So he's got about a 3.8% chance of not winning at all the entire month. That's pretty low. So if we subtract that from 1, we get 0.962. So he has about a 96.2% chance of winning at least once. And see here it says how many times during January would David expect to win? Well, that's the expected value for a binomial, which is NP. So 31 times the 0.1 would be 3.1. So we should expect to win about 3 times during the month of January. Moving over to the next page, page 14 for question 12. Mary has about a 60% chance of getting hired for a part-time job she's applying for. She also believes she has about an 85% probability of getting accepted into the college she wants the most. Now we're told that the events are independent. So we're asked, what's the probability she's successful in both ventures? Now, so that's the probability of A and B, if we call this A and this B. So if they're independent, then we just multiply those two probabilities. So we'd be 0.60 times 0.85, which is 0.51, or about 51%. In B, it asks, what is the probability she accomplishes neither? So neither, so the probability of not A and not B, neither happening, would be the probability of not A, so not getting the job, times the probability of not getting into the college she wants to. Now, if probability of A is 0.6, the probability of not A is 0.4. The probability of B is 0.85, the probability of not B would be 0.15. Subtract each of them from 1. So 0.4 times 0.15 is 0.06. So she only has about a 6% chance of being unsuccessful in both. So C, for C, we're asked, what's the probability that Mary either gets into her chosen college or gets accepted for this part-time job, but not both of them? Okay, so one happens and the other doesn't. And there's 2 ways for that to happen. So the way we would write this as a probability statement is it'd be the probability of not A, so not getting the job she wants, and but getting the into the college she wants, and then plus, and the opposite would be that she does get her part-time job, but does not get into the college she wants. Okay, so we would go the probability of not A times the probability of B, plus the probability of A happening times the probability that she doesn't get into her chosen college. So the probability of not A, remember A was 0.6, so this would be 0.4. The probability of B we're told was 0.85, plus the probability of A we were told was 0.6, and since B was 0.85, not B would be 0.15. So if we multiply these, we get these 2 values, add them, we get 0.43. Another way to think of this is this probability, it's 1 minus the probability that they both happen, minus the probability also that they both don't happen, because we're talking about one happening and not but not the other. So another way to do it, so the probability of A and B up here was 0.51, and this probability was 0.06. So if we subtract those 2 from 1, we also get 0.43. So that's another way to calculate it. So for question number 13, a poker hand consists of 5 cards, and you're asked, what's the probability of a hand containing exactly 3 jacks? So we're talking about getting a jack, so there's 4 jacks in a deck of cards, normal deck of cards, so that's why A would be 4. We're selecting 5, So R would be 5, and there's 52 cards in the deck. We're using the hypergeometric probability formula here because this is sampling without replacement. When you're dealt a hand of cards, it's not like they deal you a card, show it to you, and then put it back in the deck. Okay, that's the only way you can make it a binomial. Okay, they deal 5 different cards out. Okay, so it's without replacement. Okay, so if somebody, for example, saw that your hand had 3 jacks, they know they're not going to get 2 in theirs because there's already 3 gone. So the special kind of thing here, the jack would be 4 because there's 4 jacks, hand of 5, and there's 52 in the deck. So there's the hypergeometric formula. So A is 4, so 4 choose X. N minus A, so 52 minus 4 is 48. Choose R minus X, so 5 minus X, and then 52 choose 5 in the denominator. So 3 jacks, X is 3, so be 4 choose 3, and then 5 minus 3 would be 2, 48 choose 2 in the end over 52 choose 5. So these two combinations work out to 4 and 1128. 52 choose 5 is a fairly big number, a little over 2.5 million, and multiplies and divides to this, so 0.0017, or about a 0.17% chance. So on any given hand, you've got about a 0.2% chance of it having 3 jacks exactly. So not a very good chance. B says no jacks. So same formula here. No jacks would mean that X would be 0. So we put 0 here and here. So 4 choose 0, and this would be 48 choose 5. So there's actually a better chance of getting no jacks than getting 3. Works out to 0.659, so about a 65.9%, much higher chance of getting no jacks whatsoever. For question number 14, a raffle costs $10 and a total of 1,500 tickets were sold. The prizes and their frequencies are shown in the following table. So there is 1 $5,000 prize, 2 $1,000 prizes, 8 $100 prizes, and 25 $10 prizes. You're asked to determine the expected winnings of any given ticket. It says of each ticket, so that means of any one of the tickets. So you take each of these amounts that the person could win and multiply by the probability of that happening. Okay? Now there's 1,500 tickets sold. So the probability of this one prize of 5,000 happening, there's only one of them, the probability would be 1 in 1,500. So we would multiply 5,000 by 1 over 1,500. And then add to that 1,000 times, now there's 2 chances out of 1,500, plus 100 times 8 out of 1,500, plus 10 times, and there's 25 of those, 25 out of 1,500. And so this is what the calculation would look like. Just to show you, actually I'm going to pause and then type it all out. And so there it is. So $5.37, well, it would round to 37, I guess. So I've got 536 here. I guess I should have rounded up 1. If you type it out a little bit differently, then maybe you'll get it around to 536. But that's what the calculation would look like. So moving on to question number 15 here. A certain potato chip manufacturer makes bags with a mean mass of 320 grams and a standard deviation of 2.65 grams. You're asked to calculate each of the following probabilities. What is the probability a randomly chosen bag has a mass under 324? So we need to use the z-score formula to know what to look up on our chart here. I'll bring that over in just a moment. So we're told that we're asked to find the probability of mass under 324. So 324 goes in place of X. The mean is 320, so 320 here. And the standard deviation is 2.65, so 2.65 in the denominator. So the first thing I'd want to do is 324 minus that 320 divided by 2.65. And so that gives about 1.51. Now we're trying to find the probability it's less than or equal to 1.51. So remember 1.51. So 1.51 would be right here. Okay, there's the 0.01. The hundredths is a 1. So 1.51 would be here, 0.93448. So that's where that probability comes from. Remember, this table gives you the probability it's less than a certain value. Okay, if you want greater than, then you have to do something a little bit different, and we'll get into that in the next example. Actually, that's still all less than, sorry. B, it says, what's the probability that a bag is amassed between 315 and 326? So we'd have to do the same z-score calculation for 315 and 326. So 315 here gives us negative 1.89. And 326, we put 326 here, we get 2.26. Now, when you're doing between, you subtract the two z-score values. So we're actually looking for the probability z is between negative 1.89 and 2.26. So 2.26 would be this number right here, 0.98809. So that's where that number came from. And looking up the negative 1.89, negative 1.8, we go all the way across to 9, whoop, looking in the wrong spot. Negative 1.89 would be this. I meant to have a little bit over here. So you can see that that's where that 0.0298938 number comes from. Negative 1.89. So we subtract those to get 0.95871, so about 96% chance it's between 315 and 326 grams. Question number 16 here. 3 coins are tossed 200 times, and the number of times 3 heads comes up is noted. And you're asked in A, can the normal approximation to the binomial be used here, and asked to justify your answer. Now, the probability of 3 heads coming up, if you're throwing 3 coins, a head, and a head, is 1 chance in 8. There's 8 different ways to throw 3 coins, and only one of them has H, H, H. So P would be 1/8. Okay, and so in order to figure out if the normal approximation is good or not, you look at the value of NP. So 200 times 1/8, which is 25, and also NQ. Q would be 7/8 because 1/8 subtracted from 1 would be 7/8. Now, if those two values are both bigger than 5, that's the test, then the normal approximation can accurately be used. See, this is actually a binomial situation, but the calculation would be so huge, it's quite laborious. So the normal approximation is a lot quicker to do. So, let's calculate the probability that 3 heads comes up less than 20 times. Okay? So we already did NP up here, but that's your mean. NP is 25. And the standard deviation is the square root of NPQ. So the square root of 200 times 1/8 times 7/8 will give us 4.68. Now, less than 20, if you remember, and actually I'm going to just pause and make a drawing here. Okay, so here's my diagram. So let's say that this bar in your histogram represents 20. We want less than 20, so we don't want to include stuff in here just below 20. We're looking for this area down here. So the bottom of the bar, if all the bars are width 1, because we're talking about 20 or 19 or 18 or 17, then they're all width 1, then that point right there would be 19.5. And so when we go to use the z-score formula, we would use 19.5 in it, not 20. Okay? So the mean is 25, so 19.5 minus 25 divided by the standard deviation is 4.68 gives us negative 1.18. So the probability x is less than 20 would be the same as the probability z is less than, well, actually less than or equal to. Yeah, you actually can put an equal to sign in the bottom here, because that's what the z-scored table gives you. So negative 1.18 would be this number right here, 0.119. So that's the probability you're looking for. So about 11.9% chance that's happening. Okay, now here's actually a more than, like I was referring to in the previous page. Determine the probability that 3 heads comes up more than 33 times. Well, same idea. If this was 33 here, we want the area above it, then this point here would be 33.5. And so that's why we use 33.5 in the z-score formula. So 33.5 minus the mean of 25 divided by the standard deviation of 4.68 gives us 1.82. So the probability x is greater than 33 is the same as the probability z is greater than 1.82. Now, these probabilities are always less than. So if I'm looking up the 1.82, so we're looking up the value in the chart here, 1.82. So 1.82 would be this number right here, 0.96562. Now, that 0.96562 means that there's 96.562% is below that. So the amount that's above, we would subtract it from 1, because these values always give you the probability below that. So that's why we look up that number, but we subtract it from 1, because we don't want what's below the 1.82, we want what's above. So 0.03438, or about 3.4% chance that the three heads coming up more than 33 times. And that's the end of the review.